Hey guys, here's some examples for the equation of a tangent line. So remember, the equation of a tangent line should be in the form y equals mx plus b. It's a line that touches your curve at exactly this point only. So before we can get the tangent line, we have a point, but we need the slope. So remember, your slope equals your average rate of change, which is f of x2 minus f of x1 over x2 minus x1. And ultimately, we're going to find the limit as x2 approaches x1. So that way we're finding the slope right at that point. So remember, this is x1 and this is f of x1. We don't know what x2 or f of x2 are. So we're going to use this average rate of change to find the limit as any x value approaches but never equals x1, and then we'll have a very close average rate of change for our slope. So this is the limit as x2 approaches 2. F of x2 would be x2 over x2 minus 1. Notice I'm just plugging in x2 for my x's, minus f of x1, which is 2, all over x2, which we don't know what that is, minus x1, which is 2. So now what we've created is a complex fraction. I need to play around with this to make it one fraction over 1. So I'm going to multiply this one by x2 minus 1, x2 minus 1, and then I'll have the common denominator. So this is the limit as x2 approaches 2 of x2 minus, now notice I'm distributing a negative 2 x2's plus 2 all over x2 minus 1. And that is being divided by x2 minus 2. So now I'm going to simplify this numerator. 1x2's minus 2x2's becomes negative 1 x2 plus 2 over x2 minus 1. And that's going to be multiplied by the reciprocal of this. So now remember, when your leading coefficient is negative, you should factor out a negative GCF, which in this case is negative 1, and that will leave x2 minus 2 times 1 all over x2 minus 1 times x2 minus 2. Now this is exactly what we wanted to happen. Now these x2's minus 2's cancel, and now I have the limit as x2 approaches 2 of negative 1 over x2 minus 1, which approaches negative 1 over 2 minus 1, which is negative 1 over 1 or negative 1. So now I know my slope is negative 1. Well, I'm not done there. I need to actually find my tangent line, y equals mx plus b. But we know that m is negative 1. We need to find b. Well, the initial point that they gave us that this line has to go through is 2, 2. This is x, this is y. 2 equals negative 1 times 2 plus b. 2 equals negative 2 plus b. Adding 2, 4 equals b. So the equation of my tangent line is y equals negative 1x plus 4. All right, we'll try another one.